Hello everyone. So this will actually be my first video tutorial that I would be posting online. So let's see how it goes. So the video tutorial is regarding solving probability questions using Python. So I recently came across a book, a very good book called The 50 Challenging Problems in Probability. And initially I started solving it mathematically, and one day I thought of solving it using Python by running Monte Carlo simulations, and it was a success. So I have been solving a lot of problems since then. I am on day 16 currently. So after solving 16 problems using Python, I have got a hang of how the modeling works and how to run the simulations, run the Monte Carlo simulations using Python and to get the correct results. So let's look at the problem number 16. So problem number 16 is, will second best be the runner up? So there's a tennis tournament which has 8 players. A number of players draws from the hat decided the first round rung in the tournament ladder. And suppose that the best player always defeats the next best and that the latter always defeats all of the rest. So the higher ranking player will always defeat the lower ranking player. A better player will always defeat the worst player. So the loser of the final gets the runner-up cup. What is the chances that the second best player wins the runner-up cup? So let's look at the diagram. So in this case, it shows the tree structure of the tournament. So let us run the simulation for one or two cases. So suppose that the second best player is here and the winner is here. So in this case, winner will obviously reach the semi-final, and the second best player, knowing that the winner is not in the same subtree, will always reach the semi-final. And in this case, the second best player will be the runner-up. But in the case where the winner and second best player are in the same subtree, then obviously they will meet some time, and in this case the winner will defeat the second best player, and the second best player will not be the runner-up. So let's solve this question mathematically first, and then we'll move on to the code. So there are 4 rungs here. There are 4 rungs here in the upper subtree and the lower subtree. Now, probability is obviously number of favorable outcomes whole divided by total outcomes. So if suppose the second best player is in the upper rung, so he has 4 places to be, and the number of rungs, the winner can only be in the lower rung. So there are 4 places the winner can be. And similarly, if the second best player is here, then he has 4 places to be, and the winner has 4 places to be. Now the total number of outcomes would be how many ways we can actually permute the 2 players, like how many actual number of outcomes there can be, like how many rungs, how many different ways can they be distributed among the rungs. So suppose the winner, we are putting the winner first, so he has 8 places to be, and the second best player, now the one place would be occupied, so the second best player will have 7 places to be. This is equal to 32 divided by 56, which is around 0.57. So now that we have solved it mathematically, let's look at the code. So now let's think about how we can model this tournament in a Python script. So first of all, let us initialize an array named players, and it will have the rank of the players. Now the lower ranking player, which is 1, will always defeat 2, 3 and so on, and 2 will always defeat 3, 4 and so on. Now before we write any code, I'll like to import the random library, which should help us implement most of the randomization in our script. Now, so first of all, we'll have to fetch the first 2 players. So will player 1 and player 2 will conduct a match between them. Whoever will be the winner will append it to the end of the array. This way we'll have a moving array kind of scenario in which the current players will be playing and then the winner will be moving to the end, so that he or she can play further with the other players, other winners. So in this case, the best data structure to use would be a double-ended queue, which is also called a deck. So we will import it from collections library. We'll convert into a deck. Now let's run the simulation for just one time. What happens in one tournament, then we'll run the simulation for multiple tournaments to actually get the correct results. So P1, we will get it from the players dot pop left. P2 will be players dot pop left again. Let's try to print the P1 and P2. First we'll print the players. So as you can see, the player list is here, and in this case always 1 and 2 play the first match. So before we actually pop left, we'll have to randomize the players deck by using the random.shuffle function. Now our deck will be shuffled. So the first match is between 1 and 7, and now how do we decide the winner? We decide the winner by the rank, by the number which it has in the player's deck. So 1 will always defeat 2, so 1 will be the winner if 1 and 2 play. So winner is P1 if P1 is less than P2, else the winner is P2. This is a Python syntax that I love using. So now that we have gotten the winner, we'll append it to the end of the deck. So players dot append winner. Now let's look at how the players deck look like. So as you can see, the first match was between 1 and 2, and the winner was 1, and it has been appended to the end. Let's run the simulation again. In this case, the first match was between 2 and 8, and the winner is 2, so it has been appended to the end. Now we have to run this simulation until there are only 2 players left in the tournament. That will help us decide that 2 will actually be the runner-up or not. So we'll obviously have to do this in a while loop. So while length of players is greater than 2, we will do this loop. So let's see what the output is in this case. So as you can see, we had the initial deck as this, 1 and 6 as being the first game. Then 1 was appended to the last. Then we had 2 and 8 was appended to the last. Then we had 3 and 4 with 3 appended to the last. Then we had 1 and 2 with 1 appended to the last. And the last game was 5 and 3. So now that we have this, let's try to predict what each simulation will output. Like the cases in which the second best player is in the remaining number of players, then in that case he or she will be a runner-up. So we'll run the simulation over a bigger number. So let's set as the simulation parameter as t equal to 100,000. We'll put it in a function if simulate. Now we have to count the favorable outcomes in which the player 2 was the runner up, and in this case we'll obviously have to return 2 in TMP. So this will return true and false, and true and false they map to the value 1 and 0 in the cases that they are used as integers. Let's try to run the script. It will obviously take a lot of time because we have print statements. So let's get rid of print statements. So as you can see, we get the probability as 0.57, which is actually very close to the theoretical probability which we got by doing it mathematically, by solving it mathematically. So let's look at the comparison between doing a Monte Carlo simulation and solving it theoretically. So the simulated probability that we have, as the number of player grows, it stays quite close to the theoretical probability, and as the number of player grow, as you can see the limit of the formula, as it n tends to infinity, the value of the probability approaches 0.5, which is actually consistent with the theoretical probability that we have. So hope you enjoyed this tutorial, and this was my first tutorial and trying this for the first time, and I'll be posting much more content down the line, so stay tuned. Thank you.